Assalamualaikum and good day everyone. In this video, you are going to learn about second shifting property. If Fs is the Laplace transform of Ft, right, and a greater than 0, then the Laplace of Ft minus a ut minus a is equal exponent to the power of minus as the Laplace of the function ft, which means this is equal exponent minus a s multiplied by fs. In this slide, I'm going to introduce you what is the Heaviside function. So here is the definition of the Heaviside function. Heaviside function is in the form of ut minus a. You see this ut minus a in the second shifting property in the previous slide, which the Laplace of the ft minus a ut minus a equals exponent to the power of minus as multiplied by the Laplace ft. Alright, so what is this Heaviside function? Ut minus a is 0 when t less than a, while ut minus a is 1 when t greater or equals to a. We're going to use this Heaviside function whenever the function ft, the input function in the equation, is a piecewise function. Alright, so you can see that from here that ut minus a is split into two intervals. Alright, the first interval is when t less than a, where the ut minus a is 0, and the second interval is when t greater or equals to a, when where ut minus a is 1. Okay, so this is how we plot the Heaviside function. You can see that at the point t equals to a here, when t less than a, the function is 0. Alright, okay, and when t greater or equals to a, the function is equal 1. Okay. Practically, the second shifting property of Laplace transform is applied when the function ft is a piecewise function. Here are the steps of the second shifting property. The first step is determine the ft minus a if applicable, or else you have to apply the substitution of t equals t minus a plus a, okay, to generate the function in the form of t minus a and determine a. How are you going to determine a? Alright, if the equation, when you look at the equation, is in the form of ft minus a ut minus a, so the Heaviside function determines the a value. Okay, from the step 1, okay, we have determined the ft minus a. We're going to shift ft minus a to ft. So here is when the shifting occurs, alright, where you have to shift the function ft minus a to ft, alright. Then find the Laplace transform of ft. Okay, the next step is, once we know what is the Laplace of ft, we're going to substitute into the formula, okay, into the second shifting property, which the Laplace of ft minus a ut minus a equal exponent minus as multiplied by the Laplace of ft. Alright, in this slide, I'm going to show you 3 examples that I think I would rate them as easy examples. The first question is Laplace of ut minus a. Alright, so but before that, let's recall the formula of second shifting property. Laplace of ft minus a ut minus a equals exponent minus as fs. Alright, so in order to determine the power of the exponent here, okay, you just need to look at the Heaviside function ut minus a. So whatever a here appears here will be the power of the exponent, and in order to determine the function fs, alright, we need to shift ft minus a to ft, then find the Laplace of ft. Alright, so let's discuss the first question, Laplace ut minus a. All right, so a is unknown. All right, so we just maintain the power of the exponent is as an unknown value, exponent to the power of minus as. All right, okay, then the function f t minus a in this question is equals 1. All right, why equals to 1? Because you don't see any function, right, any or numbers in front of the ut minus a, so we know that the ft minus a is 1. All right, then we're going to shift ft minus a. Okay, we're going to shift t minus a to t, then ft is also equals 1 because 1 is a constant. All right, so whenever you do the shifting of a constant, then you get the same constant. All right, so therefore the Laplace of ut minus a is equal exponent to the power of minus as Laplace 1 because ft is 1. Laplace 1 is 1 on s, so the final answer is exponent to the power of minus as on s. If you know what is the value of a, you just need to substitute the value of a into the power of the exponential. Alright, let's move to the second question. Laplace of 4 ut minus 5. Okay, so we can see that from here, from the Heaviside function, that a is 5. Alright, so we know the power of the exponent is exponent to the power of minus 5s. Alright, then whatever in front of the ut minus a or ut minus 5 in this question is the function of ft minus 5, and this is equals 4. Right, here we need to do the shifting. Ft minus 4 equals to 4, and we know that 4 is a constant, so when we do the shifting you get the same constant, right? Because it does not affect because there is no variable of t in the function. Alright, so you don't have to change the function because it's just a constant. Alright, the Laplace of 4 ut minus 5 is equals exponent minus 5s Laplace 4. Laplace 4 is 4 on s, so therefore the answer is 4 exponent to the power of minus 5s over s. Alright, this is the third example, Laplace of t minus 3 ut minus 3. Okay, then from the Heaviside function we know that a is 3. Okay, then the power of the exponent is minus as, minus 3s. Okay, now is the time to determine the function ft. Alright, as I mentioned just now, that whatever appears in front of the ut minus a, okay, or ut minus 3 in this question is the function of ft minus 3. Alright, so ft minus 3 is equal t minus 3. Usually I like to write the t minus a in a bracket. Okay, why? Because I know that whatever in the bracket, I need to shift the term into t. Okay, just like this question. So we have ft minus 3 equals t minus 3. Then I put a bracket here. So I know that whenever I see a bracket of t minus a, I need to shift them to t. Alright, we do the shifting. We're going to change whatever t minus 3 to to t. So ft equals t. Okay, alright, shift. Okay, you shift t minus 3, all the terms of t minus 3 now becomes t. Alright, the Laplace of t minus 3 ut minus 3 equals exponent to the power of minus 3s Laplace t or Laplace ft. Okay, Laplace t is 1 on s squared, so therefore the answer is exponent to the power of minus 3s on s squared. So here is another two examples. Okay, example 4, Laplace of exponent to the power of t minus 1 ut minus 1. Alright, from here we know that a is 1. Okay, so it reflects the power of the exponential, exponent to the power of minus s. Alright, and whatever appears in front of the ut minus a is the ft minus a. So if been written here that ft minus 1 is exponent to the power of t minus 1. Alright, I'm going to put t minus 1 in a bracket because I know that the t minus a, I have to shift them, alright, to t. Alright, then we do the shifting, ft minus 1 equals exponent t minus 1. So therefore, ft equals exponent t. Okay, now we know what is the function ft. Okay, we just need to replace t minus 1 by t. Right, then we're going to put this function ft into here. Exponent minus s, Laplace of exponent t. Laplace of exponent t is 1 on s minus 1. Alright, so therefore the Laplace of exponent t minus 1 ut minus 1 equals exponential of minus s over s minus 1. Alright, let's move to the fifth question. Alright, so we have Laplace of sine t minus 2 ut minus 2. I would say that these examples are easy examples because you can see that the function ft minus a is in the form of t minus a. Alright, here we have sine t minus 2 ut minus 2. So from here we know that a is 2. Okay, then we know that the power of the exponent is minus 2s. Alright, now we want to find ft. So sine t minus 2, whatever in front of the ut minus 2 is the function ft minus 2. So ft minus 2 is sine t minus 2. Alright, so look, I write t minus 2 in a bracket. So means that whatever in the bracket, you have to shift them to t. Alright, shift ft equals sine t, where you just need to replace t minus a or t minus 2 in this question by t. Alright, so we're going to substitute the function ft into here. Alright, so therefore Laplace sine t minus 2 ut minus 2 equals exponent minus 2s over s squared plus 1. How do you get this? Is the Laplace of sine t 1 over s squared plus 1. Okay, now let's level up the examples. Alright, okay, in the 5 examples that we have discussed just now, they are straightforward because you can do the shifting straight away. Alright, now let's I want to show you how can you determine the Laplace transform using second shifting property if the ft minus a is not in the form of t minus a. Alright, okay, for example, example 6, we have Laplace t squared ut minus 1. Right, then a is 1. Okay, so we know that the power of the exponent is exponent minus as, so therefore exponent minus s. Okay, then the whatever in front of the ut minus a is the function ft minus 1. Alright, so in this case is ft minus 1 equals t squared. Sorry, I missed the squared here. This is t squared. Right, okay, then you see that the function ft minus 1 equals to t squared is not in the same as it's not in the same in the form of t minus 1. You don't see t minus 1, right? When you look at the t squared, you don't see t minus 1. Alright, so you don't see t minus 1, so how come you can perform the shifting? Okay, how can you shift t minus 1 to t? Alright, so therefore you have to create the t minus 1. Okay, however, okay, you create the t minus 1, but please do not change the equation. So the best way is we just need to let t equals t minus a plus a, where you just need to put t minus a in a bracket. You don't change the equation since when you simplify this t minus 1 plus 1, you're going to get t. Alright, you create t minus a, but you need to plus a. Okay, so to make sure that you don't change the equation. Alright, then you just need to replace t by t minus 1 plus 1. So t minus 1 plus 1 and then squared. Alright, okay, so we put t minus 1 in a bracket. Okay, again I repeat that what you need to write down t minus a in a bracket so that you know that whatever in the bracket you have to shift the t minus a into t. Alright, so therefore ft, okay, you can see that now t minus 1, t minus 1. Now you can see t minus 1, okay, in the equation. Alright, So we're going to shift t minus 1 to t. Alright, so therefore t minus 1 here becomes t. Alright, t minus 1 here is t. Then you have plus 1 squared. So you need to expand the squared. Okay, t plus 1 squared is t squared plus 2t plus 1. Alright, so we're going to substitute into here. Alright, the Laplace t squared is 2 on s cubed, Laplace 2t is 2 on s squared, and Laplace 1 is 1 on s. So therefore, Laplace of t squared ut minus 1 is exponent to the power of minus s multiplied by 2 on s cubed plus 2 on s squared plus 1 over s. Alright, now here is an example of, I would say that hard question. Alright, Laplace sin t ut minus phi, because it involves trigonometric functions. Okay, and then you don't see that the function is written uh, in the form of t minus a. Okay, a is pi, so therefore Laplace sin t ut minus pi is equals to the power is equal exponent to the power of minus pi s Laplace ft. Alright, so we have to find what is the function ft. So whatever in front of the ut minus pi is ft minus pi. So we have ft minus pi equals sin t. Alright, so you don't see, when you look at this is t minus pi and this is t. Alright, so you cannot do the shifting because it's not in the same form. You don't see t minus a, alright, to allow you to do the shifting. Okay, so the solution is you need to like generate ataupun or create the t minus a, but please make sure that you don't change the equation. So the easiest way is you let t equals t minus pi plus pi. Alright, and then just need to write t minus pi in the bracket. So you know that whatever in the bracket, you need to shift them to t. Alright, so ft minus pi equals sine, okay, t here, you replace by t minus pi in bracket plus pi. Alright, then you do the shifting, because now you can see that this is t minus pi and also this is t minus pi, so it allows you to do the shifting. Alright, where you just need to change the t minus pi by t. Okay, so ft minus pi, you change it to ft equals sine t in the bracket, t minus pi you shift to t. Okay, and then you have plus pi. Okay, and then what you can see that this is sine t plus pi. You cannot find the Laplace transform of sine t plus pi before you do this operation, where you need to apply identity trigonometric function. So this I've given you the formula. X is t, y is pi. You just need to substitute into this formula. Sine t plus pi equals sine t cos pi plus cos t sin pi. So you can see that cos pi is minus 1, sin pi is 0, so you don't have the second term. Sin cos pi is minus 1, so therefore ft is minus sin t. Right, then we substitute into here exponent minus pi s, Laplace of minus sin t. Okay, Laplace of minus sin t is minus 1 divided by s squared plus 1. Right, then you multiply by the exponent minus pi s, okay, to determine the final answer. Alright, I will show you another example. Then I'll say that this will be the last example in this video. Alright, so you have like exponent minus t ut minus pi. Okay, so we know that a is pi, so this is a. So this, the Laplace of this question is exponent minus pi s. Okay, Laplace of ft, but we don't know what is ft yet. Right, okay, then whatever in front of the ut minus a is the function of ft minus pi. So we have ft minus pi equals exponent minus t, and you can see that here is t minus pi, but you don't see t minus pi in the function. Alright, so therefore you are not allowed to do the shifting. Alright, so alternative operation that you can do is you need to let t equals t minus pi plus pi. You have to create the t minus pi. Okay, but please do not change the equation. So you're going to let here, you're going to let t equals t minus pi plus pi. As I mentioned just now, you need to write down t minus pi in a bracket. Alright, so exponent minus, you just need to replace t by t minus pi plus pi. Okay, alright, you do not change the equation. Alright, the equation is the same equation. Okay, but you want to like modify the equation so that you can do the shifting. Alright, so this is t minus pi, and you can see t minus pi, so you need to replace or shift t minus pi to t. So ft equals exponent minus t plus pi. Alright, everyone got it? Okay. Alright, so we're going to bring this function. Okay, you're going to bring this function into here. Right, so this is equal exponent minus pi s Laplace of exponent minus t plus pi. Alright, so here you need to apply the apply the properties of the exponential function. You know that exponent a multiplied by exponent b is equals exponent a plus b. Alright, so this is an exponent minus pi s. Okay, multiply by exponent pi, exponent minus pi. Alright, because we bring out the exponent minus pi. Okay, or I think, but before I simplify it, let me show you how I do it. Right, this exponent minus t plus pi is equal exponent minus t multiplied by exponent minus pi. So you can just bring exponent minus pi outside, bring it outside, okay, of the Laplace, because exponent minus pi is just constant. Alright, so this is equals to exponent minus pi s, exponent minus pi, and Laplace of exponent minus t. Laplace of exponent t is 1 over s plus 1. Alright, so again kat sini, here I can simplify. So this is exponent negative pi s plus 1. Alright, and then the Laplace of exponent minus t is 1 over s plus 1. Alright, so this is the final answer for this question. I hope that you enjoy this video. I'll see you again in the next video. Thank you.